All right, so this next topic is how to find values of inverse trig functions. The key here is asking for the exact value. So exact value in math means don't use a calculator. So if we are not expected to use a calculator, that means these problems have to be able to be calculated by hand, which in the world of trig means we are dealing with our special right triangles. All right, so our special right triangles, go ahead and just pull up a new sheet here. Our special right triangles are 30, 60, 90, and 45, 45, 90. So because, actually I'm going to do this a different way because I hate just saying here they are. I'm going to show you where they come from. So let's start with an equilateral triangle. So if it's an equilateral triangle, and we're going to say it has sides of 2. If it's equilateral, we know that all of the angles are 60. We know that if I draw an altitude here and it's an equilateral triangle, it's going to bisect that angle, so that's going to be 30. We also know that it's going to bisect this side here equally, so then we know that this piece here is 1. So you can already see part of the 30, 60, 90 being developed. So at this point, I don't need this piece of the triangle. Undo. Didn't want to erase that much. So I'm just going to leave it there. But I do need to know what's opposite the 60. So I'm going to use the Pythagorean theorem. 2 squared equals 1 squared plus x squared. So that's 4 minus 1 equals x squared. X equals square root of 3. So now I'm going to pull out that 30, 60, 90 triangle. So opposite my 30, no matter which way that triangle is drawn, opposite my 30 needs to be 1. Opposite my 60 needs to be root 3. And opposite my 90 needs to be 2. So there's our special 30, 60, 90 right triangle. So let's work with this one a little bit. So let's say that you're asked to find the inverse sine of square root of 3 over 2. So what that's saying is find the angle that has a sine, oh boy, I can't spell, that has a sine of root 3 over 2. So basically what you're solving, when does sine of theta equal square root of 3 over 2? Well, remember, sine is equal to opposite, the ratio of a triangle's opposite side, a right triangle's opposite side, to its hypotenuse. So let's go look over here. Well, which angle has a sine of square root of 3 over 2? Well, opposite the 60 is root 3, and we can see that our hypotenuse is 2. So we know that we are dealing with 30 degrees. Yikes, that's not what I wanted. We are dealing with 30 degrees. If the question wants the answer in terms of pi, we can just convert degrees to radians. So 30 degrees is pi over 6 radians, and 60 degrees is pi over 3 radians. So that would be pi over 6. Oh, sorry, I don't know why I said pi over 6. That's not the one we were looking at. Opposite of the 60. There we go. Opposite the 60 is root 3. So that's going to give us pi over 3. Opposite over hypotenuse. Okay, so what if we were looking for cosine of, inverse cosine of 1/2? Again, that's asking the angle that has a cosine equal to 1/2. So remember, cosine is a right triangle's ratio of its adjacent side to its hypotenuse. So if we go over here again, so which one has an adjacent side of 1? Adjacent means next to. So 60 has an adjacent side of 1. I know that the 2 is also next to the 60, but that's the hypotenuse, so it can't ever be the adjacent side. So adjacent is 1, hypotenuse is 2, so again, the answer is 60 degrees, or in radians, pi over 3. All right. How about sine? Let's do inverse sine of 1/2. So inverse sine of 1/2. Another way to look at that, sine of theta is equal to 1/2. So in our 30, 60, 90 triangle, sine of theta is equal to opposite over hypotenuse. Well, which one has an opposite side of 1? 30 degrees has an opposite side of 1 and a hypotenuse of 2. So it has to be pi over 6. All right, so that's if we're working with our 30, 60, 90 triangle. We also have something called a 45, 45, 90 triangle, which of course we're going to have to derive that instead of me just giving it to you. So we're going to draw a square with sides of 1. And now we're going to draw a diagonal, which we know since it is a square, it bisects it perfectly, so these angles are 45. I'm going to use the Pythagorean theorem to figure out this side here. So x squared is equal to 1 squared plus 1 squared. X is equal to the square root of 2. So that is where your 45, 45, 90 triangle comes from, or in radians, pi over 4, pi over 4, and our 90 degree is pi over 2, 1 square root of 2. So if you're asked to find the inverse tangent of 1, that's asking, again, give me the angle that has a tangent of 1. Remember, tangent is opposite over adjacent. So opposite, oops, you can't see what I'm pointing to, opposite over adjacent, next to 1 over 1. So there we have it. That is 45 degrees, or pi over 4.